Okay, hey everyone. My name is Arye, and I'm presenting to you live today from a surprisingly warm day in New York. Thanks for tuning in. So, just to go over what we'll be discussing today, this is a What is Blockchain webinar. We'll be diving deep into first Bitcoin and explaining how that works. Then we'll be looking a bit more broadly at blockchain technology and some trends to watch. We'll be talking about Ethereum, another big blockchain and a competitor in some ways to Bitcoin. We'll also touch on initial coin offerings, or ICOs, which have been all the rage recently. And finally, we'll review and open the floor to questions. So just, for some perspective, and as I'm sure we all know at this point, last year, around the same time, the market cap of all cryptocurrencies totaled $15 billion. Last week, the total market cap of all cryptocurrencies passed $500 billion, which is an increase of more than 3,000%. I don't have to tell you this, but obviously this space is super hot. And I should mention that this slide is a bit dated since last week. The market cap of all cryptocurrencies passed $600 billion today. Bitcoin's price has been a big contributor to this run-up, with the price moving from under $1,000 in December of 2015 to around $18,000 today and passing $20,000 earlier this week. Media interest has skyrocketed in tandem. Here we use the CB Insights Trends tool to look at media mentions and general interest. As we can see, media mentions of Bitcoin, Ethereum, and blockchain have gone through the roof this year as money continues to flood the sector. So let's get into it. What's all the fuss about? What is Bitcoin? In the next couple of slides, we're going to use analogies to explain Bitcoin, hopefully in a very clear and simple way. Let's begin with Alice and Bob. Let's say that Alice hands Bob a physical arcade token. Bob now has 1 token, and Alice has 0. The transaction is complete. In the physical world, this is easy. However, digital transactions look nothing like their physical cousins. Let's say that Alice sends Bob a digital arcade token, via email, for example. Let's think about this for a second. Ultimately, a digital arcade token is a string of 1s and 0s. How then can we determine the unique owner of the digital token? In other words, if both Alice and Bob know the same string of 1s and 0s, who is the real owner? Today, we solve this problem by using middlemen. A middleman will hold a database or a ledger on behalf of Alice and Bob. This ledger will track a single asset, let's say, digital arcade tokens. Because Alice and Bob trust the middleman, the ledger is now the source of truth. Whoever the ledger says is the owner of the digital arcade token, that's the owner. This is an effective solution. However, what happens when we can't trust or don't want to trust the middleman? What if Dave decides to charge a fee that neither Alice or Bob want to pay? Or what if Alice bribes Dave to erase her transaction? Maybe Dave wants the digital token for himself and adds a false transaction to the ledger in order to embezzle it, saying that Bob gave him the token. In other words, what happens when Alice and Bob cannot trust the trusted third party? Think back to the first physical transaction between Alice and Bob. Is there a way to make digital transactions look more like that? Here's a thought. Alice and Bob could distribute the ledger to all their trusted friends, not just Dave, and in a way, decentralize trust. This is possible because the ledger is digital, so all copies of the ledger can sync together. If a simple majority of participants agree that the transaction is valid, in other words, confirm that Alice actually owns the token she wants to send, this transaction gets added to the ledger. The key thing with this decentralized ledger is that when everyone holds a copy of the ledger, there's no single point of failure. Therefore, the ledger is harder to cheat. And this is, the most important point when thinking about this. So now let's get back to Bitcoin. What is Bitcoin? Bitcoin was proposed in 2008 by an anonymous creator who I'm sure many of you have heard of, Satoshi Nakamoto. Bitcoin, in many ways, was a response to a loss of trust in trusted third parties. You can see this headline here, Chancellor on brink of second bailout for banks. This was actually encoded into Bitcoin's database. again, expressing the roots of this technology. So let's think back to our analogy with Alice and Bob. Bitcoin looks a lot like Alice's and Bob's decentralized ledger, although it has some key differences. Technically speaking, and we'll dive deeper into all three of these in just a moment, Bitcoin is a decentralized public ledger. Due to its unique architecture, this ledger is known as a blockchain. Therefore, Bitcoin was the first to use blockchain technology. Instead of digital arcade tokens, like with Alice and Bob, this ledger's unit of account is Bitcoin. The ledger has encoded rules, one of which states that there will only ever be 21 million Bitcoin produced. And the last bullet here, which we'll expand upon in a moment, Bitcoin establishes consensus among untrusted nodes with a clever incentive structure involving miners. So Bitcoin looks a lot like Alice's and Bob's decentralized ledger. However, remember how we said that Bitcoin is different? The key thing to remember here is that Alice and Bob only gave their ledger to trusted friends. Bitcoin is open to anyone, even those who aren't trusted. This is an issue. How does Bitcoin get all its untrusted participants to agree on the state of the ledger? How does Bitcoin avoid the middleman if nobody can be trusted? So Bitcoin has a really clever way of solving this problem that involves game theory and incentives. Specifically, Bitcoin monetarily rewards certain participants, called miners, for maintaining and securing the ledger. Bitcoin also monetarily punishes bad actors for attacking the ledger. Okay, I know this was a lot of information to process, so let's break it down. Let's just look at a typical Bitcoin transaction. Let's say that Alice and Bob are both participants on the Bitcoin ledger, the same way that they were both participants on the ledger for digital arcade tokens. Alice wants to send Bob 2 Bitcoin. She tells all participants in the ledger that she wants to send Bob 2 Bitcoin. Remember though, how can we trust Alice? How do we know that she has 2 Bitcoin to send and that she wants to send them to Bob? Here's where Bitcoin's incentive structure comes into play. Remember, Bitcoin rewards good actors for maintaining the network and punishes bad actors for attacking the network. So first, how does it reward good actors? Certain participants, called miners, are rewarded with Bitcoin for maintaining the ledger. This is a strong incentive, as Bitcoin's been pushing $20,000 in recent days. So how does this work? Let's say Dave, another participant on the Bitcoin ledger, decides that he wants the reward. He sees Alice's transaction after she propagates it to the network and goes about verifying it. This means that 1, Dave makes sure that Alice signed the transaction, and 2, that she actually owns 2 Bitcoin to send to Bob. If the transaction is valid, Dave will then bundle Alice's transaction into a block with other transactions and work to add this newest block to the chain of prior blocks. This is, as you may have guessed, why it's called blockchain technology. Instead of an Excel spreadsheet tracking transactions, Bitcoin uses a different architecture, a chain of sequential time-stamped blocks. However, and here's the crucial point, in order for Dave to add a new block to the chain, he has to devote immense computational power to solve a math problem. Now let's expand out. All the miners on Bitcoin's blockchain use a lot of computational power. This, in turn, uses a tremendous amount of electricity. So much electricity, in fact, that a recent estimate put Bitcoin's total daily energy consumption at greater than Ecuador's, a country of 17 million people. So how does Bitcoin punish bad actors? Well, all this computational power scares away hackers and bad actors because hacking Bitcoin to get everyone's coins would cost a tremendous amount of electricity and money. And if the Bitcoin community became aware of the hack, it would likely cause the price of Bitcoin to drop steeply. This makes such an attack economically self-defeating. This mining process allows Bitcoin to confirm transactions without the use of a single middleman. Now, let's keep following Alice's transaction. If others in the network confirm Dave's work, then Dave is allowed to add his block to the chain, and he is rewarded with Bitcoin. Alice's transaction is now recorded forever on the Bitcoin blockchain. Think of a glacier, how layers of ice cover deeper layers of ice, and so on. As more blocks get added to the chain, Alice's transaction becomes more and more quote-unquote solid under layers and layers of new transactions. Alice's transaction is there for everyone to see, and the taller the blockchain gets, the more secure Alice's transaction is. Okay, that was a lot of information, but I hope you're still with us. Now for the quick definition. Again, Bitcoin is a decentralized public ledger. I think we know what that means now. Due to its unique architecture involving blocks, this ledger is called a blockchain. The only thing that this ledger tracks is Bitcoin. The ledger's rules state that there will only ever be 21 million Bitcoin mined, or given as rewards to people who maintain this ledger. Because anyone can read it and write to it, Bitcoin needs a method to establish consensus among untrusted nodes, unlike Alice's and Bob's decentralized ledger shared among trusted friends. Bitcoin uses clever incentives to establish this consensus among untrusted parties. This is how Bitcoin avoids the middleman. So here is the million-dollar question. Why is a single Bitcoin worth almost $20,000? Put simply, Bitcoin is the first decentralized, censor-proof, portable, secure, durable, and scarce digital asset. This is revolutionary. There's no middleman here, and that's a huge deal. If you think this is important or cool, then you might want to get your hands on a Bitcoin. There will only ever be 21 million Bitcoin mined. Like other commodities, Bitcoin is traded on secondary exchanges, where its price is determined. And supply and demand has determined that it's worth almost $20,000. So let's recap for a second. Now we've discussed Bitcoin, we discussed the concept of a decentralized ledger, and by the way, thank you all for staying with us through that interruption. We discussed Bitcoin, we discussed a decentralized ledger, and now we're getting into blockchain technology broadly. Okay, again, let's replace the words. Blockchain allows untrusted parties to reach consensus in a shared digital history without a middleman. So where else could this be used to track something? Where else could a blockchain be used to track something? A couple immediate use cases come to mind. Identity, a massive, let's imagine it, a massive decentralized ledger for identity controlled by nobody, yet trusted by everyone. Supply chain, tracking an item through ports, shippers, exporters, and importers. And content attribution, assigning intellectual property rights to a certain item and ensuring the correct ownership of that item on a decentralized ledger. And you can see here some of the companies that are exploring this tech for those applications. Let's take a bit of a closer look at identity. Here are 4 companies working on user-controlled identity with blockchain technology. The Equifax incident exposed the social security numbers of almost half of US citizens. I'm sure we're all aware of that. Blockchain technology might have helped avoid this. There will be no central middleman in charge of holding on to or even issuing all those social security numbers. Centralized middlemen are prime points of attack, as seen with Equifax. Healthcare is another area where blockchain technology could be applied. If a single distributed database is accessed by patients, providers, and insurers, this could have broad implications for data security, interoperability, and reimbursements. Still, we should temper our optimism, as blockchain technology has limitations. Again, let's think about this. If the trend of the past couple of years has been toward cloud computing, blockchain is a complete reversal of that trend. In blockchain technology, everyone needs to hold a copy of the same decentralized database, as opposed to in cloud computing, one server holding a copy and everyone accessing that copy. As a result, blockchain technology is having difficulty scaling. Specifically, a cell phone, let's imagine a database. A cell phone can't hold a ledger if it's 50 gigabytes. So blockchain technology has issues around ledger size. And because all participants need to update together, there's latency or a delay, and transactions take a while to process. Lastly, at least in the case of Bitcoin, miners have grown very powerful because it's easier to solve those math problems and devote lots of computational power when banded together. As a result, miners have centralized, and the ledger as well has become more centralized. On the point of mining centralization, this is a sampling of miners. You can see here that the biggest ones, Antpool, BTC.top, and BTC.com, account for more than 50% of blocks mined. All 3 of these pools are based in China. This is an issue for Bitcoin. Still, it's not that big of an issue. Again, it's not in the miners' economic interest to break or hack Bitcoin, because then their Bitcoin would lose significant value, and their power is therefore tempered. However, due to these technical challenges facing blockchain technology, it's important to understand where blockchain makes sense and where it doesn't. Specifically, blockchain technology makes sense when everyone needs a single record of ownership or a shared source of truth, and when a third party isn't trusted to hold that source of truth. As seen here, blockchains are therefore a specific subset of ledger and database technology. Distributed ledger technology, a broader solution, might make sense in many cases where blockchain doesn't. This flowchart here is a good way to understand if your problem needs a blockchain solution. Essentially, if you don't need total decentralization or a single shared source of truth, then you probably don't need a blockchain. Indeed, distributed ledger technology is being tested by some of the biggest companies in the world. This year, Walmart and IBM teamed up to test a pilot with the technology. In a test, Walmart successfully tracked food through the supply chain in a matter of seconds. Prior to this technology, the same process would have taken weeks. Again, we asked where else blockchain and DLT might prove useful, as seen on this market map, in a wide range of use cases, ranging from capital markets to healthcare to media. So at this point, we've discussed Bitcoin, blockchain, and distributed ledger technology. But can we do more with blockchain? Let's talk about Ethereum. So let's step back for a second. Bitcoin uses a blockchain to create a decentralized ledger for payments. On the other hand, Ethereum uses a blockchain to create a decentralized computer for applications. Now I know what you're thinking. What in the world does that mean? So I'll explain it. Let's say that Alice wants to make her payment to Bob conditional. Let's say they want to make a bet. Here's the bet. Alice thinks that the temperature tomorrow morning will reach 70 degrees. Bob thinks that it won't. They wager 10 Bitcoin on the outcome, which is a pretty substantial sum of money. If Alice and Bob don't trust each other, they will have to use a trusted third party as an escrow agent. In other words, they will each have to give the agent that amount of Bitcoin, and the agent will distribute the winnings and the amount staked to the winner. There's no way around the middleman in this scenario, even using Bitcoin. Bitcoin has no way of decentralizing their bet. Ethereum, though, has a way, using something called smart contracts. Alice and Bob could agree to use some basic code, an if-then statement of sorts, that pays out based on the temperature. If the temperature is higher than 70 degrees, then pay Alice, otherwise pay Bob. Alice and Bob could then place their programmed bet on Ethereum's blockchain. At that point, it becomes binding and decentralized. The code is decentralized because all Ethereum participants hold a copy, just like every Bitcoin participant holds a copy of the Bitcoin ledger. These smart contracts put together are building blocks. If we take a lot of them, we can create full decentralized applications on top of Ethereum, much bigger in scope than this simple bet between Alice and Bob. This is the Ethereum development stack. Decentralized applications at the top are made up of smart contracts. These smart contracts are placed onto the Ethereum blockchain, which ensures that they remain decentralized. Nobody controls them. Let's look at an example. CryptoKitties. CryptoKitties is a decentralized application that uses the Ethereum blockchain to create collectible digital cats. Smart contracts determine each cat's unique appearance. The Ethereum blockchain tracks ownership of these tokens, or digital cats. I believe the most expensive cat went for over $100,000 at the time. The last item we'll seek to define is an initial coin offering. An initial coin offering is when a company sells tokens to the public. Just like Bitcoin or Ether are tokens and provide utility within their network, tokens in an ICO provide utility within that network. So, how does it work? Effectively, when a blockchain company seeks cash, they can hold an ICO. Generally, blockchain companies issue a number of scarce tokens that fund the development of the network in question. Think again about Bitcoin and Ether. A good analogy for tokens is a metro system under development. Imagine the New York subway system was under construction. The company building the subway system could release a number of metro cards for the development of this new subway. If the Metro cards were in limited supply, they might rise or fall in value, depending on the future of the subway system. This obviously looks nothing like a security in the traditional sense, but other ICOs do look more like securities. The Howey test on the right side of the slide is a popular tool used to determine if an ICO constitutes a securities offering. So, why are ICOs important? ICOs and the associated tokens in some ways stand to disrupt traditional venture capital because they are effectively a non-dilutive financing mechanism. They don't take away equity from the founders. Token holders only demand that the network be built, whereas VCs demand a share in the company's future profits. Again, the company and network look very different here. In this way, tokens are challenging the status quo. And you can see here a couple of articles exploring this latest trend. Indeed, ICO funding has shot past early-stage equity funding for blockchain companies. This is a big deal, as the financing model shifts to an entirely new one. Lastly, ICOs are reflective of a broader shift in the blockchain space. If the conversation shifted from Bitcoin to blockchain in 2015, the conversation has swung back from blockchain all the way to crypto and beyond in 2017, as blockchain companies are raising financing via ICOs and reimagining what's possible with blockchain technology. Let's review. What is Bitcoin? Bitcoin is the first decentralized, censor-proof, portable, secure, durable, and scarce digital asset. Bitcoin is enabled by blockchain, which is a technology that allows untrusted parties to reach consensus on a shared digital history without a middleman. In Bitcoin's case, this shared digital history is the Bitcoin ledger. Ethereum builds on blockchain technology by incorporating smart contracts, which allow developers to build decentralized applications on top of Ethereum. These decentralized applications, like Bitcoin and Ether before them, have built-in utility tokens. These companies sell some of these tokens in ICOs in order to raise funds. With that, we'll end our presentation today and open the floor for questions. I also want to point out that further reading here, we have an article on what is blockchain technology, which has many of the points presented in this presentation, what is Ethereum, and we look closely at some of the blockchain investment trends over the past couple of years. Okay. Please reach out with questions. We have one here. What do you foresee in 2018 as far as SEC regulations around ICOs? So the SEC has been somewhat quiet as opposed to, or when contrasted with other countries and other governmental agencies. So far, they've handpicked or cherry-picked a couple of ICOs that look very much like securities offerings, and they've gone after them with the full force of the law. Many would say that the SEC is playing pretty slowly and pretty even-handedly right now in the blockchain space, in the crypto world. But again, generally the blockchain community still lacks strong guidance or strong regulatory guidelines around ICOs. And is waiting with bated breath for those guidelines to be received and be better outlined. Let's see. There's a question here. Given the incentives against hacking Bitcoin, what happened with Mt. Gox? Could it happen again? Good question. Mt. Gox, let's separate Mt. Gox for a moment. Mt. Gox was a secondary exchange in the same way that Coinbase or Bitflyer in Japan or any other exchange is separate from Bitcoin. Bitcoin can be traded for fiat on Coinbase, let's say. But again, a hack on Coinbase is not a hack on the Bitcoin network. Bitcoin is entirely separate from these centralized exchanges, and to this date has not been hacked in any real sense. Let's see. After there have been 21 million Bitcoins issued, what is the incentive to mine? So there are also small transaction fees that are associated with transactions on the Bitcoin network. This is a piece we didn't go into today, but the incentive after 21 million Bitcoin are mined, which again is in the year 2140, so we have some time, would be transaction fees. And hopefully those would be actually lower than they are today. Again, we mentioned how Bitcoin is having difficulty scaling. As a result of those scaling issues, transaction fees are relatively high right now and cause for much debate within the community. Let's see. If the blockchain technology is undeniable, then why are many calling Bitcoin a bubble? Good question. In general, we have yet to see strong or in production products with many users on certain blockchain technologies. And as a result, many are calling Bitcoin a bubble. There is no question that blockchain technology is immensely disruptive. The question is one of, I guess, network effects and who will have the most users and the most advantages due to a strong network. But obviously, don't take my word for it. There's 1,000 articles out there describing why Bitcoin is or is not a bubble. I encourage everyone to read. Let's see here. What is an example of a supply chain blockchain? So we mentioned a couple here. Again, prominent pilots in the space are Maersk, Walmart. They've had some very prominent pilots mentioned in the media. They're working with within consortia like Hyperledger. If you look back at some of our previous presentations on blockchain, we speak a lot about the role of consortia within the blockchain space and how corporates are interacting with consortia and how corporates are investing in the space. I would also point to blockchain investment trends in review to get a better sense of more projects in the space. We spoke about limitations of Bitcoin. Is there anything to keep in mind about Ether? Again, Bitcoin and Ethereum are based on very similar blockchain technology. There are obviously some differences, but ultimately both are really facing issues of scaling right now, and both have developers that are consistently and constantly proposing solutions to that scaling problem. So many of the problems in Bitcoin are shared by Ethereum and vice versa. Let's see here. How is the legal issue resolved if a smart contract is not fulfilled? So ultimately, a smart contract is a piece of code. It is not code as law, although some might say that. If it went to a court of law, a smart contract might have little to no bearing, depending on which lawyer you speak to. But as of now, there is no jurisdiction that recognizes a smart contract as legally binding, or at least superseding another, sort of a legally binding institution. Let's see. Okay, last question here. Let's see. What are the biggest advantages of an ICO versus an IPO, and what are the biggest risks? So I would just point out that an ICO is poorly named. Many in the community would tell you to call it a token launch or a token sale. It looks nothing like an IPO. An IPO is when stock is issued in a public company. An ICO is when tokens are issued for usage within a network. So going back to the analogy we had before about the MetroCard and the subway system, that's an ICO, issuing MetroCards for a future subway system to be built at some point in the future. This is also why there are tons of concerns around overcapitalization, too much money going to these ICOs, given that many of these networks are not yet in production, and this is also a prime reason why people would call this space bubbly or frothy. But again, this is not, an ICO looks nothing like an IPO. It is not an equity financing in the traditional sense, and if it is in violation of securities laws and regulations. With that, we'll end our Q&A. Thank you all for joining us, and thank you for waiting patiently through our technical difficulties. Slides will be sent out after the presentation. And please reach out if you have any questions or comments or concerns. Again, it was a pleasure, and thank you for your time.